In this video, let us discuss about an important property, viscosity. Many questions come from the first chapter from this property only. So let us see what is viscosity. Viscosity is resistance of layer to flow, resistance of layers to motion. So what does it mean? The fluid is composed of different layers. These are the molecules. Molecules will be there in these layers. And this is the surface. Let us say this is the surface on which fluid is flowing. Due to this property viscosity, the adjacent layer, if you consider this layer and this layer resists this motion. This down layer resists the upper layer motion. So that, and also there are some important points to be noted. This viscosity has another name, absolute viscosity. If in question it is given just viscosity, it means it is referring to absolute viscosity or dynamic viscosity. Absolute viscosity or dynamic viscosity. And now, what is the effect of temperature on viscosity? Let us see how is viscosity affected with different properties. Firstly, viscosity is due to cohesion in liquids. In liquids, it is due to cohesion, and it is due to intermolecular momentum exchange. Intermolecular momentum exchange in gases. So, how does cohesion affect the viscosity? Suppose these are the molecules and these are the adjacent layer molecules. What is cohesion? Cohesion is the attraction between two similar particles, two same molecules. So this molecule and this molecule have attractive forces and attract each other, so that there is a resistance to flow between these adjacent layers, because there is attraction between these molecules. This is called cohesion, and cohesion is the main cause for viscosity in liquids. If you consider particles of this solid surface and this liquid molecule, this attachment is called as adhesion. So what is intermolecular momentum exchange? In gases, let us say there is a container. In gases, if this molecule collides with this one, there will be a momentum exchange, and this travels in some direction and this travels in some random direction. In a flow, if this momentum exchange increases, there will be a random motion in different directions rather than in a particular direction. So, as how does this cohesion and viscosity changes the how does this cohesion and intermolecular momentum exchange changes the viscosity? Let us say this intermolecular momentum exchange is IMME. As cohesion increases, if cohesion increases, what does it mean? If cohesion increases, which means attraction between two same molecules increases. If attraction between two same molecules increases, viscosity also increases. Viscosity increases. If intermolecular momentum exchange increases, viscosity increases. This is because more random motion will take place, and thus the resistance to motion in particular direction increases. That means viscosity is increasing. Now let us see how does temperature affect the viscosity. As temperature increases, the distance between the molecules increases. So as the distance between molecule increases, cohesion decreases and viscosity decreases. As temperature increases, this is for liquids, and for gases, as temperature increases, intermolecular momentum exchange increases. As temperature increases, the kinetic energy of these molecules increases. So as the kinetic energy increases, that means intermolecular momentum exchange is increasing, so viscosity increases. So for liquids, as temperature increases, viscosity increases. This dynamic viscosity is represented with mu. And for gases, as temperature increases, viscosity increases. Sorry, for liquids it decreases. So if we plot a graph between these two, temperature and viscosity, this is viscosity, this is temperature. This is for liquids, this is for gas. As temperature increases, viscosity decreases. So this is liquids. And this is for gases. Temperature increases, viscosity also increases. And what is the effect of pressure? What is the effect of pressure on the viscosity? In the ordinary usage, which means in ordinary pressures that we use, no effect. There will be no change in viscosity due to change in any pressure.